do section 10.4, page 515, exercise 17, which reads, find the radius of convergence of the power series. And our series for exercise 17 is the summation from n equals 0 to infinity of n factorial times x minus 4 to the n. Now, again, we're probably going to want to apply the ratio test, but there could be negative terms in this series if x is less than 4 and n is equal to an odd number. So we're going to take the absolute value again when we apply the ratio test. And remember that if the series converges absolutely, then the original series is going to converge as well. So let's start by applying the ratio test. So I'm going to have the limit as n goes to infinity. Remember, we're going to take the absolute value. And for the ratio test, it's the n plus 1 order term. So it's going to be n plus 1 factorial times x minus 4 to the n plus 1 divided by the nth order term. So that's going to be n factorial times x minus 4 to the n. And as is usually the case when we're dealing with a ratio test, we're going to be able to cancel some things so we can do some simplification. So I'm going to have the limit as n goes to infinity. And again, I'm going to take the absolute value. Now I'm going to be able to cancel these x minus 4 to the n terms in the denominator with all but one of those terms in the numerator. So I'm just going to have a single factor of x minus 4. And then we can also do some canceling here with the n plus 1 factorial and the n factorial. So if we remember that n plus 1 factorial is going to be n plus 1 times n minus 1 times n minus 2 all the way down to 1. And n factorial is going to be n times n minus 1 times n minus 2 all the way down to factorial. When we do this division, we can cancel all of these, and we're just going to end up with an n plus 1 term. Now remember, when we're applying the ratio test, this is going to be equal to L. And if this series is going to converge, we're going to want L to be less than 1. However, if you just look at this limit, as n goes to infinity, this is going to go to infinity as well, unless one thing happens. And the only way that this is not going to go to infinity is if x is equal to 4. And if x is equal to 4, then the limit and L is going to be equal to 0, which is going to be less than 1, which means we will have convergence. But if x is equal to any other value, we're going to have L equal to infinity, which is going to be greater than 1, which means it's going to diverge. Now, you have to remember what the question asks, which is to find the radius of convergence. And this is one of those situations where, because the series only converges where x is equal to a, that the radius of convergence is going to be equal to 0.